Assalamu alaikum everyone, myself Aris Saqib and welcome you all to my presentation on software engineering. Before I begin, I would like to thank to Sir Asim for the guidance and support in helping me understand the principles of software engineering. During my presentation, I will summarize the key concepts from the first 15 lectures and share what I have learned from them. So, software engineering is not just about writing the code, it's a structured approach to designing, developing, and maintaining the software that meets user needs. Now, let's first discuss an overview of the key concepts in software engineering. First, we discuss about the SDLC, which is the core of the software engineering. Each phase ensures that the software is built to high standards from gathering requirements to delivering and improving the final product. Also, we discuss about the methodologies as well as the essential activities like testing and quality assurance, which verify the software's functionality and reliability. Additionally, software matrices and quality attributes like usability and efficiency play a vital role in evaluating performance and ensuring the software meets its goals. Throughout the process, modern tools and technologies play a crucial role in streamlining the development process, while challenges such as managing requirements, budget constraints, and scalability highlight the dynamic nature of the field. This presentation will explore all these aspects, providing a comprehensive understanding of the software engineering process. Now let's move on to the software development lifecycle, which forms the backbone of the entire software development process. The SDLC is a structured framework that guides the development of software from inception to completion. It provides a clear roadmap promoting efficiency, quality, and consistency in software development. It consists of different key phases, each designed to ensure the software meets user requirements and quality standards. The process begins with requirement analysis, where client needs are gathered and documented in software requirement specification. Next, the design phase translates these requirements into blueprint. The implementation phase follows, where developers write and test the code, ensuring that it aligns with the design and meets the specific requirements. Once the software is built, it undergoes different testing to identify and fix issues, ensuring the product is functional and reliable. In the deployment phase, the software is released to users with configuration management to handle the transition software. Finally, the maintenance phase ensures that the software remains effective by fixing bugs, releasing updates, and implementing enhancements. After understanding the software development lifecycle, it's essential to explore the different software development methodologies that guide how the phases of the SDLC are implemented. One of the most traditional methodology is the waterfall model, which follows a sequential linear approach where each phase must be completed before moving on to the next. This method is well suited for projects with clearly defined requirements. However, the main drawback of the waterfall model is its inflexibility, as it does not easily accommodate changes once a phase is completed. On the other hand, the agile model promotes an iterative and collaborative approach, allowing for flexibility and frequent adjustments throughout the development process. Scrum is a specific agile methodology that organizes the development process into time-boxed iterations known as sprints. Each sprint typically lasts 1 to 4 weeks, and at the end of each sprint, a potentially shippable product increment is delivered. In contrast, incremental delivery is a development approach where the software is built and delivered in small functional parts, while both focus on gradually delivering parts of the product. The key difference lies in the structure. Scrum follows a well-defined framework with specific rules, whereas incremental delivery is more flexible and less structured. Iterative refinements means making continuous improvement to the software by going through repeated cycles and adjusting to new needs as they come up. Requirements gathering is one of the crucial phases in software development that focuses on gathering, defining, and validating the needs of the stakeholders. It involves two main types of requirements: functional requirements, which describes the specific behaviors or the functions of the system, and non-functional requirements, which outlines the system's performance, security, usability, and other quality attributes. Together, these requirements, various elicitation techniques are used, such as interviews, surveys, brainstorming sessions, and the creation of the prototypes to better understand and refine user needs. Once the requirements are gathered, they undergo requirements validation to ensure they are clear, complete, feasible, and aligned with the project's goal. Testing and quality assurance are critical processes in software engineering to ensure that the final product is reliable, functional, and meet user expectations, in which we have validation and verification. Validation in software engineering focuses on ensuring that the product being developed meet the user's needs and expectations. Answering the question, are we building the right product? Key activities in validation including using prototypes and simulations to visualize the product early and conducting real-world testing to evaluate its functionality and usability. Techniques like black box testing, which examines the software output without focusing on the internal code, and user acceptance testing, where users test the software to ensure it meets their requirements, are essential parts of the validation process. These steps ensure that the final product aligns with the intended goal and satisfies user needs. On the other hand, verification in software engineering ensures that the product is built correctly according to the specified requirements. Addressing the question, did you build it right? It includes two main approaches, static verification and dynamic verification. Static verification involves activities like reviews and pair programming, where the code is evaluated without execution to identify errors early. On the other hand, dynamic verification focuses on testing the software through execution. The techniques like white box testing, analyzing internal structures, unit testing, testing individual components, system testing, evaluating the complete system, adapting various testing strategies such as bottom-up testing, top-down testing, and stress testing. In stress testing, we ensure that the system's behavior under extreme conditions. Together, these approaches ensure the software is reliable and meets its requirements. Next, move on to heavyweight and lightweight methodologies. In software development, the terms heavyweight and lightweight refer to the level of complexity, formality, and resource requirement of a process. Heavyweight methodologies are typically more structured and formal, involving extensive documentation, detailed planning, and significant oversight. These processes are ideal for large-scale products where predictability are essential, such as in traditional waterfall model. However, they can be time-consuming and slower to adapt to changes. On the other hand, lightweight methodologies are more flexible and informal with minimal documentation. They require fewer resources and are often used in dynamic, fast-paced environments such as with Agile or Scrum. Also, it's highly adaptable, allowing for rapid iterations and easier adjustments during the project. A presentation is a structured way of conveying information. It serves as a vital opportunity to provide a summarized view of the work, highlighting key milestones, achievements, and outcomes. It allows the stakeholders to gain a clear understanding of the project's objective, the challenges faced, and how they were addressed. A well-structured presentation ensures that the project's impact is understood, highlighting how the deliverables meet user needs or the organization goals. It also emphasizes the success of the project in achieving its target, delivering results on time and within scope. Presentations are basically of two types: market presentations and reports and demonstrations. Market presentations basically focus on explaining the project's purpose and benefits to engage the stakeholders, whereas reports and demonstrations showcase the project's functionality through detailed report and live demonstrations. Both are crucial for communicating value and ensuring the project's success. Software quality attributes are crucial in determining the overall effectiveness of a software product. Reliability refers to the ability of the software to consistently perform its intended functions under specific conditions over a defined period. Factors influencing reliability include fault tolerance, error rates, and mechanisms for failure recovery. In addition to reliability, other key software quality attributes include usability, which measures how easy and intuitive the software is for users; efficiency, which focuses on the software's ability to use resources optimally; maintainability, which refers to how easily the software can be updated or fixed over time; and scalability, which is the software's capacity to handle increased load or demands. Security is another crucial software quality attribute. It refers to the software's ability to protect against unauthorized access. A secure software system is essential for safeguarding user data, maintaining trust, and preventing potential threats that could compromise the system's integrity and functionality. All of these attributes contribute to ensuring the software performs well in real-world environments. Now, if we talk about the tools and technologies, then this image illustrates the various tools and technologies commonly used in deployment lifecycle of a modern software application, categorized into four main areas. The front-end section includes essential technologies like HTML, CSS, and JavaScript, along with the popular frameworks. The backend section highlights programming languages and frameworks, along with the database sections, covers both relational database and NoSQL options. Lastly, the DevOps section showcases tools related to the cloud infrastructures, automation, and virtualization, which streamline the development, testing, and deployment process. In software engineering, several slang terms are commonly used to describe specific practices or situations. Bike shedding refers to focusing on trivial details while neglecting significant tasks, often leading to wasted time in discussions. Yak shaving describes engaging in unrelated tasks that are necessary to complete a larger goal. Dogfooding is the practice of using one's own product to test its functionality and gain insights into user experience. A greenfield project involves starting a new initiative from scratch without constraints from previous work, offering immense creative freedom. MVP, minimum viable product, is a basic version of a product with core features designed for early testing and feedback. Lastly, DevOps emphasizes the collaboration between development and operation teams to streamline processes, improve efficiency, and ensure faster delivery of high-quality software. Understanding these concepts helps in professionals navigate and optimize various aspects of software development. During projects, several challenges may arise that need to be addressed to ensure successful delivery. One major challenge is managing changing requirements, as they can impact the project scope, timeline, and resources. The evolving nature of the user needs or market conditions may require frequent adjustments, making it important to have a flexible approach to adapt these changes. Another common challenge is budget and time constraints. Limited resource and strict deadlines often lead to trade offs, requiring careful prioritization of tasks and efficient resource allocation. Finally, ensuring software scalability and maintainability presents its own set of challenges. As project grows and evolves, the system must be able to handle increasing loads and easily update it or extend it, which require designing with long-term growth in mind while balancing immediate project needs. Finally, ensuring adequate testing and quality assurance is critical to prevent defects and ensure the final product meets user expectations. Balancing the time spent on testing with project deadlines requires careful planning and execution. Overcoming these challenges is crucial for the success and sustainability of the project. To conclude these lectures, I gained a comprehensive understanding of the structured process and methodologies that form the foundation of the software engineering. I learned how different phases, techniques, and tools work together to ensure that the development of reliable, efficient, and user-focused software. The discussions on testing and quality assurance were particularly insightful, highlighting their role in ensuring that the software is not only functional but also meet user expectations in practical real-world contexts. What stood out to me the most is the importance of the requirements engineering, especially in understanding both functional and non-functional requirements. Truly stood out to me that it emphasized how important it is to gather and validate the right needs. I realized that ensuring both types of requirements are well understood and agreed upon can prevent more costly misunderstandings and scope changes later in the development process. The emphasis on using various elicitation techniques such as interviews, surveys to accurately capture user needs. By investing time and effort into truly validating these requirements, teams can avoid unnecessary rework and align the software with both functional goals and quality attributes like usability, security, and scalability.